Hey guys, it's currently 9 a.m. I'm in the LT. I am sleep deprived, but here I'll be giving you a quick introduction to data types and variables. So, in Python, you can think of a variable kind of like a box. Inside of this box, you can put information, like it can be letters, it can be a character, it can be, in fact, a number, or even a decimal. All of these can go inside of the variables that you create. Now, when you put a value inside of a variable, the type of the variable changes. This is because letters are not the same as numbers, which are not the same as characters. Let me give you a quick breakdown of all of the different types of data that exist in Python that you should know of in simple terms. So, first up, we got the integer. So, the integer, otherwise known as int, is a number that is whole. It can be from minus infinity all the way to infinity. However, it must not be a decimal. So, for example, 8, 9, 7, minus 3, 0, or even like 7250031. Yeah, all of these are integers. They're just numbers that are whole. Okay, so the reason why integers are not the same as other data types is because you can do a lot of special math with it. With integers, you can do addition, you can do multiplication, multiplication, you can do subtraction, you can do division, you can do floor division, you can do a lot of different stuff with them. You can do modulo as well. If you don't know what some of these are, we can get to them later. But for now, I just know with integers, you can do math. However, there is an integer limit. Because of the amount of computer space that is given to a single variable, there is a maximum and minimum number that integers can take on. But for now, you don't need to worry about that. You just need to know that there is a maximum or minimum. Yeah. Okay, now, moving on, we have our next type, which I would say we could use strings. So a string, it sounds very weird, but a string is effectively just, you could think of it like a sentence. So you start off, when you're talking about strings, you have to start off with 2 inverted commas. And then you can say, for example, I don't know, Harry Potter 1, 2, 3 question mark, and then close your inverted commas. This is the value of your string, because strings are literals. You can't do math with them, but you can store anything in them that you like. So you can put numbers in them, weird symbols in them, letters, no matter whether they're capital or not capital. Yeah, you can put anything in them, and all of these are going to be inside of one string. So with strings in other languages, like C++, you can only do concatenation, which means you take a certain string, for example, string 1, and you add it to string 2. However, in Python, you can do this as well as multiplication. Like string 1, like this. You could do this. So Python's a bit more flexible with the way it deals with strings. Now that we have talked about strings, we need to talk about characters. So, in this entire weird phrase over here, you may notice it is made out of multiple small characters. For simplicity's sake, you can think of a character as anything you can type on your keyboard. But in reality, it is pretty much any single space symbol that you can write or type. Yeah. So for example, Chinese characters would be considered characters, Russian letters would be considered characters, and many other things, such as those weird math symbols that you don't generally use. They're all considered characters. Now, there's this thing called the ASCII. Wait. I think I spelled that correctly. But effectively, the ASCII is, you could think of it like a system that binds every single possible character to a number. So for example, question mark has a corresponding number. A has a corresponding number. Lowercase a has another corresponding number. Yeah. So the cool thing about characters is that when you use characters, you can convert between its character form, which is kind of like a very small amount of a string, and a corresponding integer, like 8 for example. It's not really 8, but yeah. Now, there are functions in Python that let you do this very, very easily, and we'll get to those later. But for now, you just need to know that you can do this, and that's the point of using a character. In other languages, you don't have strings. In other languages, strings are literally just a list of characters. Just like how arrays are a list of numbers, for example. But if you can't understand that idea, it's completely fine. That's maybe a bit too high level for us right now. For now, let's just focus on the basics. So that's just what you need to know about characters, which is just the smallest possible quantity in a string you could think of. Now, next up, we can think about booleans. Okay, a boolean sounds really, I don't know, weird, like you've never heard of this before, but you probably have. In fact, it's the cornerstone, it's the building blocks that make up computing. A boolean can either be 1 or 0. Or in Python's case, it can be either true or false. It is literally what you would consider binary. It's one state or another state. And this is generally used in things like checkers and flags, where you have to check whether something is true or false for an operation to take place. While you don't strictly need to use this, and you can just use integers or strings or whatever you want, it just saves memory and it makes your life way easier. So that's why it's popular and very heavily employed in a lot of places. Booleans, I would say, are the simplest out of the whole bunch because it is just true or false. And yeah, do remember the capital T and capital F because Python is a bit picky about that. Okay, now we have floats. So, you know how I told you integers can be any number that is from negative infinity to infinity, that basically has no decimal trailing behind it? Well, a float is slightly different. A float is a number that has decimals. Like this, right? And the thing about floats is that they are trustworthy up to a certain number of decimal places. If I'm not wrong, floats are trustworthy up to, I believe, 7 decimal places, while double floats are trustworthy until 15, but I could be wrong about those numbers. For now, you just need to know floats allow you to do more complicated math. For example, you want to calculate the area of, I don't know, a circle. If you were going to use pi of 3.14159265, whatever, and you wanted your final result to be accurate, you wouldn't make it an integer because then pretty much almost all of the decimals would kind of be lost, right? So you need precision. So in this case, you would be using a float. So this is very heavily employed in almost every part of computing, where if you need an exact figure, you would use a float. So floats fundamentally work because of how computers calculate using powers. So the calculation's a bit complex now, but for now you just need to know computers calculate everything in powers of 2. So you can think of it like they dedicate a certain amount of memory to talk about the actual significant figures, while they dedicate a certain amount to talk about the power. Yeah. But that's another thing you don't need to worry about for now. For now, all you need to know is that a float is just a decimal. Pretty much. Now, you may have heard me talk about a double just now, and the only difference between a double and a float is a double is twice as big as a float. That's pretty much it. You don't need to know much about that. And I don't think Python has a specific discrimination between doubles and floats, so you're good, don't worry. That should be it for the basics of data types. If you found it confusing, I am really sorry about that, but I think this should be enough for part 1. Now I'll get back on the computer and I'll teach you how to code it in Python and mess with it. Yay, hooray, awesome. Okay, bye. Hey guys, so now I wanted to go through basically the practical component of what I was teaching just now, which is data types. So earlier in that video, you may have heard me very briefly cover a thing called variables, which I told you to think about like boxes, where you can put things inside. Well, now we're gonna be using these boxes to do stuff in Python. Okay, so firstly, let's think about the different data types that we have talked about, right? Firstly, we have what? Integers. Then we have strings. Strongs. Then we have characters. I can't type today. Then we have booleans. And we have floats. Okay, so right now, here's a quick introduction to how you can deal with them firstly. So an integer is going to look like something like 1 or 2 or 32. Yeah, sure. So if you wanted to put that inside of a box, you would effectively say a equals to 1. So remember, you're always taking the value on the right and putting it in the thing on the left. So when I say equals 1, it says take 1 and put it inside of a. So after that, if I write print and in the small brackets I write a and I run it, it's gonna print out 1. So what happens if I do b equals to a and then print out b? Well, logic tells you, it says take 1, put it into a, take the value of a, put it into b, and then print b, which basically says print 1, because you're printing the value of b, which is taken from a, which is just 1. Right, so now that we know the basics of how you can deal with and manipulate variables, let's talk about how we can manipulate different types of variables. So for integers, you already know how to add integers into variables. A equals 1. Okay, fair enough. Now, if you wanted to add a certain number of values to a, you could do a plus equals to and then another number. So if I do this and I print out a, what's it gonna give us? Well, in this case, it's gonna give us 6. Why? Because it shows us, let's create a variable called a, put the value of 1 inside, and then add 5 to it. Plus equals allows you to add a certain quantity to it. Well, technically this code can also mean a equals to a plus 5, and if you do this, there is almost no difference. That value will still be 6. This is because you're still telling the code, take the value of a, which is 1, right? Add it to 5, which is 6, and store that inside a. So it's all about overriding, in a sense. But if you can't grasp this idea now, you can just stick with plus equals to. There is virtually no difference between both of them. Okay, now that you get this, if there's a plus equals, logically, there should be a minus equals, right? Correct. So you can write a minus equals 4, and then it'll execute in sequence, it'll give you the value of 2, because 6 minus equals 4, or 6 minus 4, is then 2. Right, so we get the basics of how to deal with this. We can also do multiplication and division. Yeah, and we can also do this thing called floor division. So floor division, basically what happens in floor division is it takes the lowest integer value. Let's give us an example. Assume you have a equals to 5, b equals to 3. So as you know, doing 5 divided by 3 is a very scary math operation that will result in a very weird looking decimal. Oh no, that's not cool, that's not fun. What if I wanted it to be an integer? Well, I could just add another slash. Then it would just give me 1. Why? Because it rounds it to the integer that you need to, that's closest basically. So in this case, 1.66667 will round to 1. And if I, for example, turn this from this into 4/3, should still give me 1. Yeah. And if I turn this into 7/3, it should give me 2. Yeah. So you can mess around with the values and you can see how they affect each other. and experiment on your own, I recommend, so that you can get a better feel of how floor division works. If you don't want to memorize, you don't need to. Remember, in computing exam, you're literally given 1 quadrillion chances per question. You can run your code as many times as you possibly want. So yeah, you can experiment, mess with things here and there, test things out. You don't need to memorize syntax exactly, that kind of thing. Okay, now that we've gotten that out of the way, let's talk about our next data type, which would be strings. So if I wanted to create a string, I would have to, again, write a variable, like a box. And inside of that, I would put, in inverted commas, the value I needed. Like here. In this case, what you're effectively doing is saying, take the literal here and put it inside the box X. The thing about this is you can't do math with it, but you can add it to other strings and you can manipulate it. How can we do that? Let's try X equals to X, like this. And then print X. What happens now? Let's run it. Let's see what happens. It says here. Why is that? It's because it says, take the value of X, multiply it by 2, and store it in X. So you say, take the value of X, which is here, multiply it by 2, which is here, and put that value in X, and then print it out. So you can do a lot of very, very interesting things, just like how you can manipulate integers. You can do a very similar thing with this kind of thing, with strings. So, for example, if I want to write spacing dude, and I run it, it's gonna give me here dude. Because again, just like integers, you can add it. Except when you add integers, it does math. When you add strings, it just concatenates. Okay, now that we got strings out of the way, what about characters? Okay, so in characters, there are 2 functions you need to know. One, ORD, and one, CHR. So ORD, it turns your string, or your character in this case, into an integer. So let me give you an example. Assume I have ORD of 8, right? I run it. Oh, whoops, I didn't print anything. My bad. So if I do print ORD of 8, I run it. It's gonna give me 97. That's because, remember, like I told you, every single possible character you can think of has a corresponding numerical value. In this case, the lowercase a corresponds to 97. And if I wanted to get back the letter A, I could do 97 without the inverted commas. And instead of ORD, I need to do CHR. If I roll this, it's gonna give me lowercase a. That's the way you can kind of manipulate certain things using ASCII. Okay, now that we've gotten characters out of the way, let's talk about booleans. So, booleans are effectively true and false. Let me give you an example. If I create X and I want to make it a boolean, I could do true. And if I want to later set it to false, I could do X equals to false. It's very simple, it's very clear cut. Yeah. If I print out the value of X, it's going to give me false. Again, it'll give you exactly what you define it to be. And remember, we didn't make this a string. We did not use this. All we did was give it an exact value. Yeah, Python takes this as on and off rather than the literal words true and false. So do keep that in mind when you're dealing with booleans. Okay, now the last one we need to talk about is floats. So in terms of floats, all you need to know is for floats, you gotta use it in a similar way that you use integers. Yeah. So x equals to 3.14159265, etc. In this case, if you use floats, you can do the exact same things you do, like plus equals 4. You can do x minus equals 2. You can do times equals to 5. However, if I'm not wrong, I don't think you can do floor division. X divided by 4. Or maybe you can. Wait, no, sorry. 4 divided by x. I don't know if you can actually. Let's try. Again, it's an incredibly niche test case, but I am not particularly sure. Wait, hold on. Yeah, I don't think it works the same in terms of floor division. Because again, floor division with a float should be quite messy. But yeah, for now you just need to know it does pretty much the same things that integers do. So, now that we've come to the end of that, how do we make certain data types, other data types? For example, let's assume we have a box with 3 inside, right? And I want to, for example, say hello 3. I could print out hello, right? With this, what if I wanted to print out plus 3? Not plus 3, plus x. What would happen? Let's roll. Oh, whoa, what is this? We get an error. Can only concatenate string, not integer to string. What does that mean? Well, over here, it is an integer. Remember, you put it to 3, so it's an integer because there's no funny inverted commas. So you can't add an integer to a string. So what do? You have to learn about this thing called typecasting. Typecasting basically turns one data type into another. So if I do x equals to 3 and the next line I do x equals to strx, what's gonna happen is x is now gonna equal to 3. Do you see the difference between this and line 7? It's because of the inverted commas. So what's going on right here is because of your typecasting, you've changed the data type for the value of x. Instead of it being the number 3, which you can do math with, now it's the literal 3, which you can add on to your other strings. So if I do this, I can typecast it over here. Whoops, what was that? Sorry about that. I can typecast it over here, for example, and it gives me hello 3. If you want, you can also typecast it here with str3. Yes, it should also work. No matter where you typecast it, just ensure that by the time your x gets here, it is a string and no longer an integer. Now, typecasting works for multiple other things as well. You can do it between, I believe, a few other data types. But for now, that should be the basics of what you need to know for data types and variable manipulation. And just remember, no matter what, the rule of thumb in terms of variable manipulation, when things get very messy, is just you take what's on the right and you put it inside what's on the left. So if I do x equals 4, it's saying take the value of 4, oops, my indentation. If I take the value of 4 and put it inside of x. However, I can't do 4 equals to x because that would mean take the value of x, which has not been defined, and put it inside of 4, which is a real existing number, which just doesn't make sense. So yeah, I hope you've enjoyed this tutorial. It's a very basic run through of how you can basically understand the basics of data types. I think this should be reasonably comprehensive. If you need me to cover more or if you need me to answer any questions, please do reach out to me. I'll be happy to help. Okay, goodbye. Don't die.